Now let's continue with section 6.6, and the fourth type of problem that you're going to encounter are problems involving speed or distance problems. Now we're used to using the formula in this format, d equals rate times time. However, in this section we're going to notice that we'll need to solve the distance formula for t and use it in this format. Time is equal to distance divided by rate. As you read through this first problem, you see that the plane was able to fly 465 miles with the wind, 345 miles against the wind in the same length of time. If the speed of the wind was 20 miles per hour, find the speed of the plane in still air. So our unknown is the speed of the plane. In any distance problem, there's usually at least two portions of the problem. In this case, it's the travel going and the travel returning. So let's begin to gather the details that they've given us. It says here that the plane flew 465 miles with the wind. So with the wind means that that 20 mile per hour wind was adding to the speed of the plane. So we have the distance going and we have the rate going would be x plus 20. The distance returning was 345 and it was against the wind. So that means that the 20 mile per hour wind was slowing down the plane by that much. So x, the speed of the plane minus 20. Now that we have d and r, we can actually find t, realizing that time is equal to distance divided by rate. So we take this distance, 465, and divide it by the rate x plus 20. We do the same thing here, divide. So notice this is a little different than what we've done in the past where we were just multiplying across. However, what's nice again about using the chart, organizing the details, is that the final column will present our equation. Notice they said they did this in the same length of time, the two portions of the trip. So we're going to set these equal to each other. Time going, time returning against the wind, we have them equal to each other. This is an equation with fractions. Specifically, it's set up like a proportion, one fraction equal to another, so we can do the cross products. So 465 times x minus 20, 345 times x plus 20. Using the distributive property, this is what we would get. And then moving your terms that contain a variable to one side, so subtracting 345x, moving your constants that don't contain a variable to the other side, so adding the 9,300 over here, this is what we would end up with. You then divide both sides by 120 and we come up with x equaling 135 miles per hour. Remember, this was the speed of the plane in still air. If you take a look at this next problem, also involving distance, we have two joggers. One is going 8 miles per hour, one 6 miles per hour. The slower jogger arrives at the end of the run a half hour before the other. Find the distance. Well, they were running a race. They both started at a specific initial point and they're talking about at the end of the run. So the distance is going to be the same. We don't know what it is, but we say, okay, we have the faster jogger and the slower one. Remember, there's always two portions at least in our distance problem. So we have their distances as x and x. The rate of one jogger, the faster one, the rate of the slower one. Time, remember, is distance divided by rate, so d divided by r. And then the fact that their times differed by 1/2 of an hour. So here again, we have our final equation is going to come from the last column, but unlike most of the times where we would add these two and set it equal to this, we have to realize that we're talking about a difference in time here. All right, now let's consider the faster jogger would be running the race in the least amount of time. So this time here would actually be the smallest amount. The slower jogger would run in more time, specifically a half an hour more than the faster jogger. So one of the ways we could set this up, and I show you three separate ways here, is we could take, first of all here, the faster jogger, which has the least amount of time, and say that he would be equivalent to the slower jogger who actually took more time minus 1/2. So if we took the slower jogger's time and subtracted the 1/2 hour that it took him extra, it would equal the faster person's time. Or we could say the faster person's time plus 1/2 hour would equal the slower jogger's time. Or we could say the slower jogger's time, which again would be more time, right? Minus the faster jogger's time, which is less, would equal the 1/2 difference. So a difference between the two, but you had to put the person who had the most amount of time jogging, which was the slower person, first. So you have 3 different ways you could have set up this equation using the information from the final column. I'm going to go ahead and solve this first one. And either one you solve, either of the 3, you would end up with the same final answer. So anyway, solving this one, it's an equation that has fractions in it, so we need a common denominator for 8, 6, and 2. You can factor each denominator and then choose each factor to the highest power. So we would choose 2's to the 3rd power, and we would choose a 3. So we end up with 2 to the 3rd, which is 8, times 3 would give us an LCD of 24. So when you multiply both sides of the equation by 24, and then cancel as I did here in the green, you would end up with 3x equals 4x minus 12. Subtracting 4x from both sides, I get negative x equals negative 12. Dividing by a negative 1, we get positive x equals positive 12. Remember, x was representing the distance that they ran, so x equals 12 miles. The 5th type of problem that you're going to encounter in this section involves translating English words into math symbols. You are going to translate problems that involve consecutive integers. Remember, this is the way we represent them. Or consecutive even or odd integers. And remember, this is the way we represent those. Let's take a look at this example. The sum of the reciprocals of 2 consecutive integers is negative 15 over 56. Find the 2 integers. So looking at keywords, sum means addition, so I'm going to be adding the reciprocal. Reciprocal means to flip the numerator and denominator. So I'm finding the reciprocal of 2 consecutive integers. Well, consecutive, remember, is represented x and then x plus 1 for the first 2. Is, remember, means equals negative 15 over 56. So here we have the first consecutive, its reciprocal, flipping it, would be 1 over x. The second consecutive, its reciprocal would be 1 over x plus 1, equals to the negative 15 over 56. So that's my equation in blue. It has fractions in it, and so what we're going to do is find the LCD, which would be 56, x, and x plus 1, all multiplied together. So we multiply both sides of the equation by that LCD. In green, I'm showing you what is canceling out, and then what would be left here would be the 56 times x plus 1, 56x, and then here negative 15x times x plus 1. When you use the distributive property to get rid of the parentheses, this is what you would get. Over here, using the distributive property, this is what you would get. Combining like terms on the left side, 56x and 56x gives us the 112x. When you get down to this line right here, you realize, wow, we've got a quadratic equation because I see x squared as the highest power. So I'm going to put it in standard form, moving everything to one side. So I chose to move the 15x squared over by adding it, and the negative 15x by adding it as well. So we end up with 15x squared plus 127x plus 56 equals 0. Since it's a quadratic, you can solve it by factoring, or you can solve it by using the quadratic formula. I chose to try factoring, and so this was the combination that worked. First times first, I used 15x and x because I had a very large middle portion. To get 56, the last times last, I used 7 and 8, and it worked out to give us the 127x in the middle. You set each portion to 0 and solve, and we got a negative 7/15, or x equal a negative 8. Now, we were looking for 2 integers. Remember, integers are the positive and negative whole numbers. So from negative infinity, you have things like negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on to positive infinity. No fractions, no decimals, just whole numbers that are positive, negative, or 0. So negative 7/15 would not qualify because it's a rational number, a fraction, not an integer. And so we're going to use negative 8 as our first consecutive integer, x. And so what would the next one be? Remember, it is x plus 1, so negative 8 plus 1, which would be negative 7. What I have here are just a few more examples of the different types of problems that I have shown you already. So taking a look at this first one, you have two trains going in opposite directions. It helps at times to have a picture. So here's a very simple picture. They started here and they're going in opposite directions. They left at the same time. One train travels 15 miles per hour faster than the other. In 6 hours, the trains will be 630 miles apart. So notice I labeled the entire distance apart 630. Find the speed of each. So we have two trains, like I said, two parts to our distance problem, and let's see what they told us. They talk about the one train being 15 miles per hour faster than the other. We don't know the distance of either one, but if we label one of them x, the other could be x plus 15. They do tell us the time that they traveled was for 6 hours, so that's the same for both. So since we have something for rate and time, we can go ahead now and multiply those together to get distance of the first train and distance of the second train, multiplying straight across. The total distance between them is 630. So now our final column gives us our equation once again. We're going to have the distance of the first train, 6x, plus the distance of the second one should equal the total distance between them of 630. So when you use the distributive property to get rid of that, combine your like terms, 6x and 6x, subtract 90 from both sides, then divide by 12, we end up with x being 45. Well, that was the speed the first train was traveling. How do we get the speed of the second one? Do 45 plus 15, which is 60 miles per hour. Take a look at this next example. This one talks about there being 16.3 out of every 100 active duty personnel being women. This looks like a rate, so this is a proportion problem. The first one was a distance. This looks like a proportion example. So we write down that first rate and we set it equal to, let's see, 535,370 total personnel in active duty. So that's a total number. It should go with the same place in the denominator that the total number went in the other ratio. What we're looking for is how many of those are women. Remember, with proportions, we can do cross multiplication. So 100 times x set equal to 16.3 times 535,370. Multiply that together, then divide both sides by 100, and this is how many out of that total were women. 87,265 out of that many were women. Take a look at this next problem. 3 postal workers can sort a stack of mail in 20 minutes, 30 minutes, and 60 minutes respectively. Find how long it would take them to sort the mail if they worked together. So this looks like a work problem. Remember, I like to do fraction plus fraction in this case equal one job done. Total time together on top, which we don't know, so we place an x everywhere. And then in the denominators, we put the individual rates of each person, so 20, 30, and 60. This is an equation with fractions, so we're going to get rid of those fractions by multiplying by the LCD of 20, 30, and 60, which happens to be 60. Over here to the side, you can see where I broke down each number into its prime factorization. And then remember the LCD, we take each factor to the highest power. So I'm going to take 2, but I'm going to take 2 to the second power because that's the highest degree it appears. I'm going to take 3 to the first power because that's the highest degree it appears, and I'm going to take 5 to the first power because that's the highest degree it appears. 2 squared is 4, times 3 times 5 gives us the 60, which is the LCD. Multiplying both sides of the equation by 60, you see what cancels here in green, giving you 3x, 2x, and x over here, remembering to multiply that by 60. Then combining like terms, we get 6x equals 60, divide both sides by 6, and we get x equals 10. So that means it takes 10 minutes for them to complete the job if all 3 of them are working together. That completes section 6.6.